Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, probability is a fundamental mathematical tool which measures and treats the uncertainties. By uncertainty, we mean something about which we are not sure. Let us explain it by some examples. We know that a coin has two sides. One is called head, the other is called tail. If we toss a coin, it will come to the ground and we will have two possibilities. We will have a head or we will have a tail. Now the coin is in my hand. Before tossing the coin, if I want to know what is the possibility that I will get a head, then this is an uncertain situation because I want to measure something before it happens. Now consider that we have two coins, and if we toss both coins simultaneously, then we will have four possibilities. Both will be heads, both will be tails. The first one is tail, the second one is head, or the first one is head, the second one is tail. Now, before tossing the coins, if I want to know that what is the possibility that I will get both heads, then this is an uncertain situation because I want to measure something before it happens. And now consider that we have 100 coins. And before tossing these 100 coins, if I want to know that what is the possibility that I will get all heads, then this is an uncertain situation because I want to measure something before it happens. Let us see another example. Suppose today is a sunny day, but I want to know what will be the weather tomorrow, after 10 days or after 20 days. Then this is an uncertain situation because I want to measure something before it happens. Suppose I am a businessman. My company is on the top this year, but I want to know the position of my company after 1 year or 5 years. Then this is an uncertain situation because I want to measure something before it happens. The world is full of uncertainties. And to measure such type of uncertainties, we need a mathematical tool, and that mathematical tool is called probability. To see the mathematical definition of probability, we need to know about some basic concepts. The first concept is statistical experiment. We say that a process of measurement or observation is called a statistical experiment. If someone is tossing a coin and we are observing for 10 minutes, then that process is called a statistical experiment. If someone is watching the number of cars passing from a certain point in 10 minutes, then that is an experiment. The next concept is a trial. A single performance of an experiment is called a trial. So a trial is the only one or the first or a single performance of an experiment. The next concept is outcome, which is also called a sample point. We say that the result of a trial is called an outcome. If we toss a coin, it comes to the ground, and if the result of that trial is a head, then head is an outcome. A sample space is a set of all possible outcomes of an experiment. If someone is tossing a single coin again and again, all the possible outcomes of that single coin are head and tail. So the set of head and tail is called a sample space. Event is any subset of the sample space. And now let us define probability. If we are given any event A, which must be a subset of a sample space S, then we can find the probability of that event. The probability of A is denoted by P of A, and it is defined by this formula, which means that probability of A is equal to number of all possible outcomes in A divided by number of all possible outcomes in S. Number of all possible outcomes in A are denoted by N of A, and number of all possible outcomes of S are denoted by N of S. So we can say that P of A is equal to N of A divided by N of S. This is the basic formula for probability. We shall use this formula to solve different questions and examples. In example number 1, we need to find a sample space for an experiment in which a single coin is tossed. When we toss a single coin again and again, all the possible outcomes are only two, head and tail. Representing these outcomes in a set, we get a sample space. So a sample space for this experiment is S is equal to H, comma, T. If we toss two coins simultaneously, then the sample space for this experiment is constructed by using this method, in which we construct a table. In this table, on the horizontal side, we represent the outcomes of one coin in red color, which are head and tail. The outcome of another coin on a vertical line in black color, which are head, tail. Now writing this black head with red edge, we get the first possible outcome, which is HH. And then this black head with red tail, we get the second possible outcome, which is head, tail. Then this tail with red edge and then with red tail to get TH and TT. So these are all possible 4 outcomes when two coins are tossed simultaneously. Representing these 4 outcomes in a set, we get a sample space. So this is a sample space for this experiment. Example number 3. Find a sample space if 3 coins are tossed simultaneously. Also find the probabilities of the following events. Number 1, when all tosses are same. Number 2, when at least 2 heads occur. In solving any problem or probability, the first task is to construct a sample space. To find a sample space, when we toss 3 coins simultaneously, we use the method of this table. In this table, on the horizontal side, we represent the outcome of 2 coins when they are tossed simultaneously. And on the vertical line, we represent the outcome of the third coin. Now, to find the outcomes when we 3 coin toss simultaneously, we write this red head with black HH and we get HHH, this outcome, that all heads occur. Then we write this red H with HT and we write HHT. Then with TH we write HTH. Then we write this red head with TT and we find HTT. In a similar procedure, we write this red T with HH, then with HT, then with TH, and then with TT, and we get all these outcomes. Representing these outcomes in a set, we get a sample space. And if we count, there are 8 outcomes. So n of s is equal to 8. In the experiment of coins, all the possible outcomes must be equal to 2 power n. N is the number of coins. If n is 1, 2 power 1 is equal to 2. We will have only 2 outcomes. If n is 2, 2 power 2 is 4, so we can get 4 outcomes. If n is 3, then 2 power 3 is 8. So we get 8 possible outcomes. And now let us find the probability of the first event, which we represent by A. So A contains only those possible outcomes in which all tosses have the same results. So we can pick those outcomes from the sample space. So there are 2 outcomes. One is this one, that all the outcomes are heads, and the other is this one, which shows that all outcomes are tail. Representing these 2 outcomes, we get the event A. And now to find probability of A, we need n of A, which is equal to 2. Using the basic formula, probability of A is equal to n of A divided by n of S. Substituting the values, and after simplification, we get that probability of A is 1 over 4. If we multiply this with 100, we get that probability of A is 25%. To find the probability of the second event, we represent that event by B, which contains only those outcomes in which there are at least two heads. So the first one is HHH, the second one is HHT, then HTH, and the last one in which there are at least two H is this one, THH. So we get an event B here. Now to find the probability of B, we need N of B, which is equal to 4. Using formula, P of B is equal to N of B divided by N of S, and substituting the values, we get that probability of B is 1 over 2. Multiplying with 100, we get that probability of B is 50%. In example number 4, we find the sample space when we roll a single die, and the probability of that event which contains those outcomes which are greater than 2. We know that a die has 6 sides. On one side there is one dot, on the other there are two dots, then 3, 4, 5, and 6 dots. So all the possible outcomes when we roll a die are 6. Representing these outcomes in a set S, we get a sample space, and we can see number of all possible outcomes in this sample space are 6. To find the probability of an event which represents that the outcomes appeared on the top are greater than 2, we represent that event by A. So A is equal to 3, 4, 5, and 6. These 4 are those outcomes which are greater than 2. So N of A is equal to 4. Substituting values in the basic formula probability, we get that probability of A is 4 by 6. If we simplify this and multiply with 100, we get that probability of A is equal to 66.7%. Now let us solve this last example, in which we need to find a sample space when we roll two dice simultaneously. We also need to find the probabilities of these three events. To find a sample space, we present the outcomes of one die in black color on the horizontal line, and the outcome of another die in red color on the vertical line. Now we combine this red one with black one to get the first possible outcome, which is 1, 1. It means if we roll two dice simultaneously, one possibility is that we get 1, 1. Then we combine this red one with 2, then with 3, 4, 5, and 6 to get these outcomes. In a similar way, we write red 2 with 1, 2, 3, 4, 5, and 6 to get these outcomes. Then 3 with 1, 2, 3, 4, 5, and 6. Then 4 with 1, 2, 3, 4, 5, and 6. Then 5 with 1, 2, 3, 4, 5, and 6. And then 6 with 1, 2, 3, 4, 5, and 6. So these are all the possible outcomes when we roll two dice simultaneously. Writing all these outcomes in a set which is called a sample space. If we count all these outcomes, 1, 2, 3, up to here, we can see there are 36 possible outcomes in this sample space. In the experiment of dice, all possible outcomes will be equal to 6 power n. N is the number of dice. And now let us find the probability of first event, which says sum of outcomes is greater than 10. We denote that event by A. And now from these outcomes, we pick only those whose sum is greater than 10. So one is 5, 6. If we add 5 with 6, the sum is 11, which is greater than 10. So we write it here. The other one is 6, 5. We write it here. And the last one is 6, 6. We write it here. N of A is equal to 3. Using this formula, probability of A is equal to N of A divided by N of S. Substituting the values and simplifying, we get that probability of A is 8.33%. To find the probability of second event, which says product of outcomes is less than 6, we represent this event by B, and in B, we write those outcomes from here whose product is less than 6. Just like 1 into 1 is 1, the product is less than 1. 1 into 2, 1 into 3, 1 into 4, 1 into 5, 1 into 6. And from here, we write all those outcomes in B, and that is the required event. If we count all outcomes, we can see N of B is equal to 10. We use the basic formula, putting the value of N of B and N of S, and then to find in percentage the solution, we multiply with 100. So probability of B is 27.78%. And now let us go for the last event, which says all tosses are same. We represent this event by C. In C, we write only those outcomes which are same, just like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. We write all these here, and we can see N of C is equal to 1, 2, 3, 4, 5, 6. These are 6 outcomes. So P of C is equal to 6 divided by 36. Multiplying with 100 and simplifying, we get that probability of C is 16.67%. That's all.